All right, let's talk about hydrogen. It's got this amazing reputation as the ultimate clean fuel. But today, we're going to peel back the layers and ask, is it really as clean as we've been led to believe? I mean, this is the dream, right? It's the promise we always hear. You use it as fuel, and poof, all you get is pure water. On the surface, it sounds like the perfect, absolutely flawless solution for the climate. And there's the catch. If it burns so cleanly, how on earth are we looking at a carbon footprint of 630 million tons a year? That's a staggering number. We're talking as much as the entire economy of Canada. So let's dive in and figure out what's really going on. Okay, so the whole story really starts with how we actually make most of our hydrogen. The number one method is a process called steam methane reforming, or SMR for short. It's responsible for about 2/3 of all the hydrogen produced globally, and guess what its main ingredient is? Natural gas. And this right here is the fundamental chemistry. You take one molecule of methane, that's your CH4, and you react it with two molecules of superheated steam. Now look at what comes out the other side. You get four molecules of the hydrogen you want, but you also get one molecule of carbon dioxide. It's not a bug, it's a feature. The CO2 is literally baked right into the chemical recipe. All right, for all my university students watching, let's get our hands dirty and actually walk through the numbers. We're going to calculate the absolute minimum amount of CO2 you can possibly get. So if you look at the mass of the stuff coming out, 1 mole of CO2 weighs 44 grams. The 4 moles of hydrogen, they weigh a total of just 8 grams. That gives us a super clear ratio. For every 8 grams of hydrogen you make, the chemistry has to create 44 grams of CO2. A little division, 44 divided by 8, and that gives us our baseline. So here it is. Even in a perfect world, a theoretical lab with 100% efficiency, the laws of chemistry dictate that for every single kilogram of hydrogen you produce, you are guaranteed to generate 5.5 kilograms of carbon dioxide. There's just no getting around that basic fact. But of course, we don't make hydrogen in a perfect theoretical world. We make it in massive industrial plants. And those factories need a ton of energy just to keep the lights on and the reactions going. And all that energy creates its own emissions. Let's see how that stacks up. Now, this is where it gets really, really interesting. Check out this chart. That 5.5 kilograms we just calculated from the pure chemistry, well, turns out that's only about half the story. The energy you need just to run the plant nearly doubles the total carbon footprint. So let's break that down a bit. This SMR reaction, it needs a crazy amount of constant heat. We're talking between 700 and 1,000 degrees Celsius. Where does that heat come from? From burning more natural gas, which adds about 1.4 kilos of CO2. You also need tons of steam, which means, you guessed it, burning more natural gas, adding another 1.4 kilos. Then you've got the electricity for all the compressors and pumps. And you even have to account for methane that leaks from pipelines before the gas even gets to the factory. It all adds up. And when you put all those real-world emissions together with the basic chemistry, you arrive at the final number. The true carbon footprint for every kilogram of hydrogen made this way is 10.5 kilograms of CO2 equivalent. Now, let's look at the global scale, because this is just mind-boggling. You take that 10.5 kilogram figure, you multiply it by the 60 million tons of hydrogen we make this way every year, and you get that massive number from the beginning, 630 million tons of CO2 equivalent. Just this one industrial process emits as much greenhouse gas as the entire United Kingdom. Wow. Okay, so now that we know the true carbon cost, here's a fascinating question. What happens if we take this gray hydrogen and use it to replace the very natural gas it was made from? Say, for heating a big industrial furnace. Are we actually helping the climate? Let's do a head-to-head comparison. We're going to look at the total life cycle emissions. That's everything from the gas well all the way to the furnace to get 1 gigajoule of useful heat. First, from just burning natural gas directly, and second, from using our SMR hydrogen. Okay, just look at this table for a second. With natural gas, you get some emissions upstream from leaks and processing, and then the direct emissions from burning it. With hydrogen, sure enough, the direct emissions at the furnace are zero. That's the clean part. But holy cow, look at its upstream footprint. It is enormous because of all the fossil fuel energy we had to burn just to create it. And here is the absolute kicker. When you add it all up, using this hydrogen for heat actually generates 42% more life cycle emissions than if you had just burned the natural gas in the first place. Think about that. You've gone through all this trouble to make a clean fuel, and you've actually made the climate problem worse.
All you've done is shift the pollution upstream and amplify it.
So, why does all this matter? What does this really tell us about the future of hydrogen as a clean fuel we can count on? This brings us to what might be the single most important point. Hydrogen is not an energy source. It's an energy carrier, just like electricity is. You don't find it just lying around, you have to manufacture it. And that means its environmental impact, its cleanness, is totally determined by how you made it. And that leaves us with a real challenge ahead. Look, the promise of clean hydrogen is absolutely real and incredibly exciting. But the way we make it today, this gray hydrogen from natural gas, it's often not helping. So to unlock that true zero-emission potential, we have to find a way to overcome the huge costs and scale up cleaner methods, like green hydrogen made from renewables. That is the real hydrogen revolution that we're all waiting for.